In this problem, we have a capacitor connected to a voltage with a switch. As soon as the switch is closed, the current will start moving within the circuit, charging the capacitor, and the charge on the capacitor Q is given by the capacitance times the voltage. If we are given that the capacitance is 0.25 micro, so that's 10 to the minus 6 farads, times the voltage, which is 12 volts, then we get a charge of 3.0 times 10 to the minus 6 coulomb. And since the charge is discretized, we can say that the number of electrons we have is the total charge over the charge of one electron. So this is 3.0 times 10 to the minus 6 coulomb over 1.6 times 10 to the minus 19 coulomb per electron. And this gives us 1.873 times 10 to the 13th electrons. And now if we want to find the depth of the separation between the plates, we can say that the density of the electrons, little n, is this capital N, the number of electrons per volume. So that equals the number of electrons divided by the area times the separation between them. Excuse me. Which means that the separation is the number of electrons we have divided by 8 times n. And we have all of these values, so we can plug in 1.873 times 10 to the 13th electron divided by the area, which is given as 2 times 10 to the negative 4th meter squared, times the conduction density of electrons, which is 8.49 times 10 to the 28th electrons per meters cubed. And if we do all of this, we get about 1.1 times 10 to the minus 12th meters. This is also known as 1.1 picometers. P stands for pico in this case. So either one of these numbers is okay.